Good afternoon, students.
Good afternoon.
Okay, all of you please switch on your videos. What are the topics that we were discussed in our last class? Any idea?
Electric power.
Electric power. Did you understand the topic? What do you mean by electric power? But the last day's performance were very poor. I am not satisfied with their performance in the last class. So today I am thinking to rethought the same topic, electric power, and we can do some numericals regarding with it. Okay. After that we can move to the revision session. Okay. So let us see what you mean by electric power. So power is a term that we are all familiar with from our smaller classes itself. Power means the strength of a person. Okay, that is, it is the rate of doing work. The rate of doing work is known as power. Then what do you mean by electric power? So here we have a definition for electric power. What do you mean by electric power? It is the rate at which electric energy consumed or dissipated. It is the rate at which electric energy, it can be either consumed or dissipated outside, is known as electric power. So this is the definition for electric power. Okay, so first of all we discuss, or we are going to define the electric power, and we can study the equation for electric power. After that we can move to the electric energy. So first of all, you must thorough with this term. What do you mean by electric power? The electric power is one of the most necessary things in our daily life. Okay, that is, it is the rate at which the electric energy consumed or dissipated from an electric circuit. From where? From an electric circuit. From an electric circuit is known as electric power. Are you okay with this definition? It is the rate at which electrical energy consumed, that we can take into for our household purposes, or it is the rate of energy that is dissipated, that we are using after the usage of this electricity. Some amount of energy is dissipated outside in the form of heat and all. So it is the amount of, or it is the rate at which the electric energy consumed or dissipated from an electric circuit is called electric power. This is the definition for electric power. Now, the mathematical equation for calculating electric power is given by, can you recall the equation for calculating electric power? P is equal to, anyone? Very good. P is equal to VI. This is the mathematical equation for calculating electric power. So we can say electric power is the product of voltage and current. So can you differentiate each term present in this equation, where P represents power. What about V? V. Unmute and say, I need to hear, listen your sound. S. V. Voltage. And what about I? Current. Yes, current. So power is the product of voltage and current. This is the mathematical equation for calculating electric power. Not only this equation, we have two more equations are there for calculating the electric power. So before that, what is the SI unit of electric power? SI unit.
Watt.
Yes, SI unit of electric power is watt. Okay, SI unit of electric power is watt. But this unit of SI unit of electric power, that is watt, is a small unit. It is a small unit. This is a small unit. So in actual practice, we describe the electric power in terms of a large unit. The large unit of power is kilowatt. This is the large unit of electric power. Okay, the SI unit of electric power is watt, but it is small unit. So in actual practice, we use a large unit to measure the electric power. The large unit to measure the electric power is known as kilowatt. And what is the relation between watt and kilowatt? 1 kilowatt is equal to dash watt. 1 kilowatt is equal to
1000.
very good, 1000 watts. This is the relation between watt and kilowatt. So this relation is necessary for doing the numericals. 1 kilowatt is equal to 1000 watts. Okay. Again, we know the equation for calculating the electric power. P is equal to product of voltage into current. P is equal to VI. And what is the SI unit of power? SI unit of power, electric power.
Joule.
SI unit of electric power. SI unit. That is what is we were discussing.
Watt.
Yes, watt.
Watt.
Watt is the SI unit of power. So can you define 1 watt? What is 1 watt? It is the product of potential and current. Then try to define 1 watt.
1 volt into 1 ampere.
Very good. 1 volt into, what is the SI unit of current? 1 ampere. So 1 watt is equal to 1 volt into 1 ampere. So define 1 watt. What is 1 watt? 1 watt is the power consumed by an electric circuit. All of you write the definition for 1 watt. It is the power consumed by an electric circuit that carries define 1 watt. That is what is we are discussed now. Define 1 watt. It is the power consumed by. It is the power consumed by an electric device. Consumed by an electric device or electric circuit that carries how much amount of the current? 1 watt is equal to 1 volt into 1 ampere. So that carries how much amount of current?
1 ampere.
Yes, that carries 1 ampere current. That carries 1 ampere current and operates at a potential of dash, fill in the blank, and operates at a potential of 1 volt. Okay, because power is the product of voltage. Power is the product of voltage or potential into current. So we can define 1 watt. 1 watt is equal to 1 volt into 1 ampere. That is, it is the power consumed by an electric circuit that carries 1 ampere current and it operates at a potential of 1 volt. So if the electric circuit is operated at a potential of 1 volt and if it is carries 1 ampere current, then we can say that that electric circuit possesses a power that is equal to 1 watt. So if an electric circuit is possess 1 watt, it need to satisfy 2 conditions. What are the 2 conditions need to satisfy by the electric circuit? It should be operate at a potential of 1 volt and it must carries a current that is equivalent to 1 ampere. Is it clear? Clear or not?
Ma'am.
Okay. So yesterday we discussed about, in the last class we discussed about the power. This is the basic equation, mathematical expression for calculating the power. P is equal to VI, where P is the power, V is the voltage or potential, both are same. And I is the current. SI unit of power is watt, but it is a small unit. So in actual practice we describe it in terms of a large unit that is given by kilowatt. And the relation between watt and kilowatt is given by 1 kilowatt is equal to 1000 watt. Then 1 watt is equal to 1 volt. 1 volt into 1 ampere. Okay, now we can describe equations for power. So the basic equation for power is this: P is equal to V into I. The basic equation for calculating the power is given by P is equal to V into I. But by Ohm's law, so this is the first equation, one equation for calculating the power. But by Ohm's law, what is V?
IR.
Yes, V is equal to IR. By Ohm's law, V is equal to IR. Therefore, equation 1 becomes P is equal to IR into I, or we can write P is equal to I square R. Very good. P is equal to I square R. This is the second equation for power. Again we can give one more modifications to the first basic equation. So we get one more equation for power, that is P is equal to VI. Again by Ohm's law. By Ohm's law, what is I? What is I? Nirupama. By Ohm's law, what is I? V by? No, here. By Ohm's law. Ohm's law is V is equal to IR. Then what is I? By Ohm's law, what is I?
R by V.
I. We kept the I here and take the R to the LHS. So it becomes? No idea. No. Basic mathematics. Here V is equal to IR. Students, all of you listen here. V is equal to IR. So I need an expression for I. I put the I or kept the I here itself, and I want to take this R to the LHS. So here R is the multiplication. When I am take this R from RHS to LHS, it becomes division. I is equal to V by R. I is equal to V by R. So by Ohm's law we know that I is equal to V by R. Therefore again our equation 1 becomes P is equal to V into, instead of I, what we can substitute here? V by R. So the equation becomes P is equal to V into V. What is V into V? Who is your mathematics teacher? Yes, V square. Uma ma'am. Okay, all right. Thank you. Anyway, at least you say the name of the teacher. P is equal to V square by R. P is equal to V square by R. So this is our third equation for calculating the power. P is equal to V square by R. Okay. So here we derive three equations for calculating the electric power of an electric circuit. So once again I am going to recollect all these equations. What is our basic equation for calculating electric power? Adidev?
V into I.
P equal to V into I, Vi. Very good. Arjun, second equation for calculating power. P is equal to
V square by
yes, V square by R. All right, no problem. Now we have one more equation is there for calculating the power. What's that? Savio. P is equal to Vi, P is equal to V square.
application I was not able to write.
S.
I square
Very good. I square R. I square R. So here we have three equations for calculating the power. The first one P is equal to Vi, second one P is equal to V square by R, and the third one P is equal to I square by R. So by using these three equations, we can calculate the electric power of a device. Okay. Can you differentiate each term present in this equation, children? What is V stands for? V for? V. Anyone?
Voltage.
Voltage. V stands for voltage, or we can say it is the potential. Voltage or potential. Okay. Then what about R? R. Rifa. Rifa, are you there? Anyone? R. This is what is I am saying in the very beginning of the class. Now you are very
Yes,
silent. Okay, what is R stands for, Rifa? R.
Resistance.
Resistance. Then what about I?
current.
Current. Good. Electric current or simply the current. And what about the term P stands for?
Potential.
P, power. P is power. If you say it is a potential, then my class is becoming an utter failure. Okay. So here V is the voltage or potential difference, R is the resistance, I is the current, and P is the power. Okay. So all these three equations are very, very important for calculating the power. So my next question to Ashik. Ashik feeling very sleepy. Out of these three equations, which equation we can prefer in order to calculate the power if the value of current is not provided? Unmute and say, Ashik.
P is equal to I square.
Listen my question. I want to calculate the value of power of an electric circuit, but the value of current is not provided. So which equation I can use here to calculate the electric power?
P to the base by R.
Yes, the second equation, P is equal to V square by R. Students, all of you listen. In the first equation, both the voltage and the current is present. So if the question with the voltage and current is given in the question paper, then you can use the first equation for calculating the electric power. But in the second equation, which term is absent? Second equation, which term is absent? I. So if in your question paper you want to calculate the power in the absence of current, you can use the second equation, P is equal to V square by R. You don't need to worry whether the value of the current is not provided. Just divide the value of resistance from that of the potential, then also you get the value of electric power. Then which term is absent in the third equation for calculating the electric power? V. The potential is not given. Okay. So in your question, if the potential is not given, you don't need to worry. We have another equation for calculating the electric power, that is P is equal to I square R. So these are the three equations for calculating the electric power. All of you just go through this equation. I am going to ask the equation now itself. Try to study the three equations of electric power now itself. P is equal to Vi. Second equation, P is equal to V square by R. And the third equation, P is equal to I square R. Is it okay? Okay, now I want to ask all the three equations. Starting with the Aman. Equation for calculating electric power with voltage and resistance. Aman? No response. I think it is better to not.
V square by R.
Okay, but the answer is given by Savio. Okay, Savio, good. The next question to John. Give the equation for calculating the power with voltage and current.
VI.
P is equal to VI. Haynes Steve. Equation for calculating the electric power with voltage and resistance.
P equal to
Voltage and resistance. No idea. Vishnupriya. Equation for calculating the electric power with the current and resistance.
I square R.
P is equal to I square R. Then Rizwan. Equation for calculating power with the current and voltage. Rizwan. The same question to Adil. Equation for calculating the power with the voltage and current.
P is equal to VI.
Okay. Johan. Equation for calculating the power with the current and resistance. Johan. So that's all about the electric power. We have three equations. One is P is equal to VI. Second one, P is equal to I square R. And the third equation, P is equal to V square by R. There are three equations are there for calculating the electric power. And the SI unit of electric power is, Prajot, what is the SI unit of electric power?
Watt.
It is watt, but it is a small unit. So in our daily life, we are used to expressed in a large unit, that is kilowatt. And then 1 kilowatt is equal to 1000 watt. Okay. Now the last topic of this lesson, electric energy. All of you write the next subheading, electric energy. Electric energy. Write the definition for electric energy. It is the product of power and time. It is the product of power and time. It is the product of power and time. Electric energy is the product of power and time. Write the mathematical equation for calculating electric energy. Electric energy is equal to, can you form an equation for calculating this electric energy? It is the product of power and time, or we can say electric energy is equal to
Power into time.
Yes, power into time. Power into time. That is what is we are written on this definition. Electric energy is the product of power and time. Electric energy is equal to power into time, or you can represent it in letters. That is, electric energy is equal to electric energy is equal to P into T, PT. Electric energy is equal to PT. It is the product of power into time. The simple way to remember the electrical energy is equal to PT. It is equivalent to PT. Now, the SI unit of electric energy is SI unit of electric energy, or the unit of electric energy watt hour. Because power, the unit of power is watt, and that of the time is taken as hour. It is expressed as hour. So unit of electric energy is watt hour. But this watt hour is a small unit of electrical energy. In order to express them in the larger unit, we are expressed the commercial unit of electrical energy is kilowatt hour. Okay. Commercial unit of electric energy is kilowatt hour. Or you can write kWh. To represent this kilowatt hour, you can write kWh.
Yes, ma'am.
And here you have the conversion. 1 kilowatt hour is equal to 1 kilowatt hour is equal to 1 kilowatt is equal to how many watts? 1000 watts. So 1 kilowatt is equal to 1000 watt into conversion of hour into second, 60 minute into 60 second, 60 minute into 60 seconds. So it becomes 1000 watt into 60 into 60, 3600 seconds. That is equal to 36000, 2 more 0 watt second, or you can write 3.6 into 10 raised to 6 watt second.
Yes, ma'am.
Okay, so this conversion is very, very important, or in short term you can note it is 1 kilowatt hour is equal to 3.6 into 10 raised to 6 watt second. In terms of joules, we have 3.6 into 10 raised to 6 joules. Watt second is equivalent to joule. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 watt second, or 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules.
Yes, ma'am.
Okay, so that's all about the electric energy. So here the definition of electric energy is very simple. It is the product of power and time. So if you know the value of power and if the time is given, then you can easily calculate the electrical energy consumed by a device using the equation electric energy is equal to power into time, that is PT. Okay, and the SI unit of electric energy is watt hour, but it is a small unit. Watt hour is a small unit. So the commercial unit of electric energy is kilowatt hour. It is represented by kWh. Now the conversion of kilowatt hour into watt second. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 watt second, or 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. Okay, is it okay? Any doubt regarding with electric power and electric energy? Unmute and say at least yes or no.
No, ma'am.
Amen.
Okay. So write one problem. An electric heater is connected to 330 volt generator. 330 volt generator. The current is 0.6 ampere. So here an electric heater is connected to 330 volt generator and the current is 0.6 ampere. Then what is the power of electric heater? What is the power of electric heater? So here an electric heater is connected to 330 volt generator. The current is 0.6 ampere. What is the power of electric heater? What is the equation for calculating the power?
P equal to V into I.
Okay, we have three equations are there, but here we have voltage and current, so we can use the first equation. P is equal to V into I. What is voltage?
330.
Yes, V is equal to 330 volt. What is current? I
0.6 ampere.
0.6 ampere. Then calculate power. Power P is equal to VI. 330 into 0.6.
190.
Yes, it is 1.
90.
Yeah.
98.0.
Yeah, 198.0. 198.0 unit. SI unit.
Watt.
Watt. Okay, 198 watt. All right. Then I will give you another problem. It is not based on the electric power. You just try to work out it. Here you have the question. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. First of all, you write the parameters that are already given in the question. So what all things are given here?
Resistance.
Yeah, resistance R. R is equal to 20 ohm, right? Then
Electric current.
current I is equal to
5 ampere.
5 ampere. Good. Then time is also given T. T is equal to 30 seconds. And
30 seconds.
yeah, right. Then what we want to find here?
heat developing, that is
Calculate the heat developed, that is, we want to calculate H. Can you recall the equation for calculating the heat developed in an electric circuit? Very good. H is equal to I square RT, and this equation is known as dash, fill in the blanks. This equation is known as,
Joule's law of heat.
very good, it is known as the Joule's law of heating effect. H is equal to I square RT. So substitute the values into the equation. 5 square into 20 into time t is 30. So 5 square means 25 into 20 into 30. That is 25 into 20 into 30. 2 into 3 6. 600. What will be the final answer? 25 into 6. And add that 2 zeros to the final answer.
One 15,000.
Yeah. 25 into 66, that is 150, then 2 zeros. So 15,000. What about the unit?
15,000.
Yeah, 15,000, right answer. Unit of heat?
J.
J, joule, right. So 15,000 joule. Okay. Last question. Which one? About the electric power? This one, dear? Okay. So P is equal to VI, 330 into 0.6. So it becomes 198.0 watt.
Yes, ma'am.
Okay. Now write one more question.
And can you show that question?
Alright. An electric heater is connected to 330 volt generator. The current is 0.6 ampere. And what is the power of electric heater? An electric heater is connected to 330 volt generator. The current is 0.6 ampere. What is the power of electric heater? So here they given the volt and current ampere. So we can use the first equation for calculating the power. P is equal to VI.
Okay, ma'am.
Alright. Now try to write one more question. An electric motor takes 5 ampere from a 220 volt line. Determine the power of the motor. Determine the power of the motor. And the energy consumed, and the energy means electrical energy, and the energy consumed in 2 hours. An electric motor takes 5 ampere from a 220 volt line. Determine the power of the motor and the energy consumed in 2 hours.
Ma'am, will you say one more time?
Here you can see the question on the board. An electric motor takes 5 ampere from a 220 volt line. Determine the power of the motor and the energy consumed in 2 hours.
Okay, ma'am.
Okay children, we can solve this problem. Did you get the answer? Here the current, value of current is provided and the value of voltage is given. So the first question, determine the power of the motor. How we can calculate the power of the motor? What is the equation for calculating the power of the motor?
P into
Yes, P is equal to VI, right. What about the voltage? V?
220
220 into value of current is given
5
5. So 220 into 5, 22 into 5.
110.
Yes, 110, and here you can put this 0 also. So the power becomes 1100 units
The
watt. 1100 watt. Okay. And here it consists of a sub question. What is the sub question? What is the energy consumed in 2 hours? What is the equation for calculating the energy consumed? Equation for calculating electrical energy?
P into T.
Yes. Electric energy is equal to PT. P into T. What is the value of power? Power is already calculated. 1100 into time. What is time?
2 hours
2 hours. You can substitute the 2 directly. So 1100 into 2, that is equal to 11 into 2, 22, 00. So 2200 unit of electric energy,
whatever.
watt hour. That's all. Okay. So that's all for today, students. Now